On the night of May 12, 2019, a telescope in Hawaii was tracking a massive star in the constellation of Aquila. It was a red giant, thousands of times brighter than our sun, burning with the fury of a dying god. The astronomers were collecting routine data, expecting the star to burn for another 10,000 years before exploding into a glorious supernova. But at 3:14 in the morning, something impossible happened. The star did not explode. It did not fade slowly over centuries. It simply blinked out. 1 second, it was a blinding beacon of plasma, and the next second, there was only a hole in the darkness. No explosion. No gamma-ray burst. No debris field. It was as if a cosmic hand had reached down and snuffed out a candle. The astronomers checked their equipment, assuming a sensor failure or a cloud passing in front of the lens. But the equipment was functioning perfectly. They checked with other observatories in Chile and the Canary Islands. They all reported the same terrifying anomaly. A massive object, heavier than our entire solar system, had vanished from the universe in the blink of an eye. What the astronomers were witnessing was not a death, but a murder. The red giant had not collapsed on its own. It had been eaten. It had crossed paths with the deadliest predator in the galaxy. A predator that has no face, no light, and no reflection. It is an object so dense that it punctures the fabric of reality, and it is completely invisible until it is too late. We are talking about a rogue black hole. And the most terrifying part of that night in 2019 was not that a star died. It was that until the moment of the attack, we had no idea the killer was there. It was lurking in the darkness, silent and cold, waiting for something to wander too close. Now, imagine that same invisible monster, not thousands of light years away, but drifting silently through the outer edges of our own solar system. This is not science fiction. This is a mathematical certainty that NASA is desperately trying to quantify. If you appreciate the darker side of space and want to stay ahead of the cosmic threats that others ignore, make sure you are subscribed to the channel. We analyze the data that keeps astronomers awake at night. To understand the threat, we must first strip away the popular image of a black hole. When you see a picture of a black hole in a movie or a textbook, you see a glowing ring of fire, the accretion disk. This is the superheated gas and dust swirling around the drain, screaming in X-ray light as it falls in. That glowing ring is like a neon sign saying "Here I am." But that is only what a feeding black hole looks like. A feeding black hole is messy and loud. It is anchored to a location, usually the center of a galaxy or locked in orbit with another star, feasting on its partner. These are the ones we can map. These are the ones we can see from billions of light years away because they are shining beacons of destruction. But the universe is full of something else. Something much more sinister. The vast majority of black holes are not feeding. They have already consumed everything nearby, or they were born in isolation. These are called quiescent black holes. They have no glowing ring of fire. They emit no light, no heat, and no radiation. They are simply spheres of pure gravity, perfectly camouflaged against the black background of deep space. They are the sharks of the cosmic ocean, and right now, they are not biting. They are swimming. And they are swimming fast. Astronomers call them rogue black holes, or wandering singularities. These are the nomads of the Milky Way. They do not orbit a star. They do not settle in a cluster. They move through the galaxy with a terrifying independence, cutting across the orbital planes of other systems, ignoring the traffic laws of stellar physics. A rogue black hole is a stellar corpse that has been kicked out of its cradle. Let us look at how these monsters are born. Typically, a massive star ends its life in a supernova explosion. The core collapses, crushing matter down into a point of infinite density. Usually, this new black hole remains in the neighborhood of its birth. But sometimes, the supernova explosion is asymmetrical. Imagine setting off a stick of dynamite inside a metal safe, but the explosion pushes harder to the left than to the right. The force involved is astronomical. The newborn black hole receives a gravitational kick, a massive punt that launches it through space at speeds exceeding 500 kilometers per second. At that speed, it breaks free from the gravity of its parent star cluster. It becomes unmoored. It begins a lonely, billion-year journey into the void. For a long time, we thought these wandering monsters were rare. We assumed that most black holes stayed put. But recent computer simulations ran by the University of California, Berkeley, have shattered that assumption. The simulations suggest that our Milky Way galaxy is not a peaceful spiral of stars. It is a shooting gallery. The data indicates that there are anywhere between 10 million and 1 billion stellar mass black holes floating through our galaxy right now. Let that number sink in. 1 billion invisible traps, drifting between the stars. The distance between stars is vast, which is usually our safety net. We often say that space is mostly empty. If you shrank the sun down to the size of a grapefruit and put it in New York City, the nearest star would be another grapefruit in Los Angeles. That is a lot of empty room. But a billion black holes changes the odds. It turns the empty space into a minefield. And unlike a mine, these explosives move. They are traversing the galactic disk, bobbing up and down through the spiral arms, passing through star systems, and exiting into the deep void again. The scary reality is that we would never see one coming until it was practically on top of us. Our telescopes, like the James Webb Space Telescope or the Hubble, rely on light. They look for photons. A rogue black hole offers nothing to them. It is a void in the data. The only way to detect one is through a phenomenon called gravitational microlensing. This happens when the black hole passes directly in front of a distant background star from our perspective. The intense gravity of the black hole acts like a magnifying glass. It bends the light of the background star, causing it to brighten and warp for a few days or weeks before returning to normal. This is how we found the first definitive rogue black hole only recently. It was a ghost moving through the crowded center of the galaxy, 5,000 light-years away. We saw a background star warp, twist, and brighten, but there was nothing there causing it. We calculated the mass of the invisible lens, and it was 7 times the mass of our Sun. It was undeniable. We had caught a ghost. But here is the problem with microlensing. It relies on perfect alignment. It requires the black hole to pass exactly between us and a bright light source. It is like trying to find a piece of coal in a dark cellar by waiting for it to pass in front of a tiny crack of light in the wall. If the black hole is approaching us from a direction where there are few background stars, or if it is coming from the dark void above the galactic plane, we would be completely blind to its approach. This brings us to the most chilling realization. We map the asteroids that threaten Earth. We track the comets. We know the orbits of the planets and the moons. We have built a comprehensive map of the solar system's threats. But that map is based on things we can reflect radar off or see with telescopes. A rogue black hole does not show up on that map. It could be lurking in the Oort cloud, that vast shell of icy debris surrounding our solar system, right now. It could be slowly perturbing the orbits of comets, sending them hurtling toward the inner solar system, and we would blame the comets, never seeing the puppet master pulling the strings from the shadows. The physics of a black hole encounter are violent and absolute. It does not need to hit Earth to destroy us. In fact, a direct collision is statistically unlikely. The true danger of a rogue black hole is its gravity. It carries the mass of 10 or 20 suns packed into a sphere the size of a city. If such an object were to pass even within a few billion kilometers of our solar system, a distance that is a stone's throw in cosmic terms, it would unravel the delicate clockwork of our planets. The solar system is a balanced equation. The planets stay in their lanes because the sun is the dominant gravitational anchor. Introduce a second, invisible anchor that is 10 times heavier than the sun, and the equation falls apart. We often think of the solar system as a permanent fixture. We see the sun rise every day and assume it will always be there. But in the face of a rogue black hole, our solar system is as fragile as a house of cards in a hurricane. The intruder would not even need to enter the planetary region to cause chaos. Just a flyby through the outer darkness would be enough to stretch the orbits of Jupiter and Saturn. And when the giants move, everything else suffers. But what if it didn't just fly by? What if it was captured? What if the trajectory was not a near miss, but an intercept course? The scariest scenario involves a rogue black hole entering the inner solar system at high velocity. It would be invisible to the naked eye until it began to distort the starlight behind it, creating a mesmerizing and terrifying funhouse mirror effect in the night sky. By the time we saw that distortion with our eyes, the gravitational tidal waves would already be tearing at the Earth. The oceans would not just have tides, they would be pulled from their basins. The crust of the planet would flex and crack, triggering volcanic eruptions on a scale not seen since the extinction of the dinosaurs. This is the monster in the dark. It is not a question of if they exist, we know they do. It is a question of their path. And recently, astronomers analyzing data from the Gaia Space Observatory have noticed strange anomalies in the movements of nearby stars. Stars that should be moving in straight lines are wobbling. Stars are accelerating for no apparent reason. It suggests that there are massive, invisible objects moving through our local neighborhood, disturbing the water as they pass. The universe is not a static painting. It is a chaotic, violent ocean, and we are drifting on a small raft. We have been lucky for 4 billion years. But in a galaxy with a billion wandering hunters, luck is not a strategy. As we peer deeper into the darkness, we are starting to realize that the shadows are not empty. They are full of gravity. They are full of hunger. And one of them might be closer than we dare to admit. But the terrifying truth is that we are not just looking for a needle in a haystack. We are looking for a needle that is indistinguishable from the hay until it pricks you. To understand the true scale of this invisible ocean, we have to stop thinking of space as empty. We have to start thinking of it as a fabric, a sheet of rubber that is constantly being stretched and pulled. Every star, every planet, and every moon creates a dip in this fabric. But a rogue black hole creates a bottomless pit. And right now, our sensors are calibrated to look for light, not for pits. This blind spot in our technology is the equivalent of standing on a train track and closing your eyes, assuming you are safe because you cannot see the train coming, even though you can feel the rails vibrating beneath your feet. The vibration of the rails is exactly what astronomers are hunting for now. They call it dynamical friction. Imagine a ship moving through water. It creates a wake. The water ripples and churns behind it. A rogue black hole moving through the interstellar medium, the thin gas and dust between stars, does something similar. It creates a wake of gravity. As it pushes through clouds of hydrogen gas, it pulls the gas in behind it, creating a density spike that trails the object like a ghost. This wake exerts a gravitational drag, slowing the black hole down over billions of years, but more importantly, it heats up the gas. It doesn't heat it enough to shine like a star, but enough to glow faintly in the radio spectrum. This is the faint whisper we are listening for. A static hiss in the silence that says, something heavy just passed through here. And we may have already heard it. In the data returning from the Voyager 1 probe, which is currently over 24 billion kilometers away from Earth, there have been unexplainable glitches. Voyager is our most distant outpost, a lonely sentinel drifting in the space between stars. Occasionally, it sends back telemetry that defies our models of the interstellar medium. The plasma density spikes unexpectedly. The magnetic field lines twist in ways that the solar wind cannot explain. Most scientists attribute this to the turbulence of the heliopause, the border where the sun's influence ends. But a growing minority of astrophysicists are asking a darker question. What if Voyager is feeling the wake of something else? What if it is sailing through the outer ripples of a passing giant? This brings us to the Oort cloud. This is the shell of icy debris that surrounds our solar system, extending nearly a light-year out into the void. It is the graveyard of the solar system, filled with trillions of frozen comets. It is also our first line of defense, and our first warning system. If a rogue black hole were approaching the solar system, the Oort cloud would be the first casualty. The gravity of the intruder would act like a bowling ball hitting a pyramid of pins. It would scatter comets in every direction. Some would be flung out into the galaxy, lost forever. But a significant percentage would be flung inward, toward the sun. Toward us. This is why astronomers get nervous when they see statistical anomalies in long-period comets. If we suddenly saw a spike in the number of comets appearing from a specific quadrant of the sky, it would be the cosmic equivalent of seeing birds fleeing from a forest fire. It means something is disturbing the nest. And recently, mathematical models regarding the mysterious Planet 9 have taken a disturbing turn. For years, we have suspected there is a massive ninth planet lurking far beyond Pluto, explaining the strange orbits of dwarf planets like Sedna. But despite our best telescopes, we have never seen Planet 9. We have only seen its gravity. Two physicists from the United Kingdom and the United States published a paper suggesting that Planet 9 might not be a planet at all. They proposed that the object tilting our solar system might be a primordial black hole. This is a different class of monster entirely. Unlike the stellar mass black holes we discussed earlier, which are born from dying stars, primordial black holes are ancient. They were born in the first second after the Big Bang, created not by collapsing stars, but by the collapse of the universe's own density during its chaotic birth. These objects could be tiny. The Planet 9 black hole, if it exists, would be roughly the size of a grapefruit. Pause and visualize that. A grapefruit. An object you could hold in your hand, yet it contains 5 to 10 times the mass of the entire Earth. If this object is real, and if it is orbiting our sun right now, it is the ultimate stealth predator. It would have no accretion disk. It would be too small to block out starlight effectively. It would be practically invisible to every instrument we possess, yet it would be the absolute ruler of the outer solar system. And if a grapefruit-sized black hole can hide in our own backyard, imagine what is hiding in the deep water of the galaxy. The danger of these smaller, primordial black holes is their density. If a rogue stellar black hole, the big ones, entered the solar system, the disaster would be gravitational. It would rearrange the orbits. But if a tiny primordial black hole were to hit the Earth, the physics would be different. It would be like a bullet. Because it is so small and heavy, it wouldn't just pull on the Earth, it would pass straight through it. Imagine a bullet shot through a watermelon. The black hole would enter the Earth's crust, punching a microscopic tunnel through rock, magma, and the iron core. It would exit the other side in minutes. But the passage would not be silent. The gravity of the object is so intense that as it tunneled through the Earth, it would trigger a supersonic shockwave in the planet's mantle. The friction would release energy equivalent to millions of nuclear weapons detonating underground. It would cause global earthquakes of magnitude 10 or higher. It would shatter tectonic plates. And then, just as quickly as it arrived, it would be gone, exiting into space, leaving a ringing, broken planet behind. This is the scenario that keeps planetary defense officers up at night. We have plans for asteroid impacts. We can nuke them, we can ram them with spacecraft, we can paint them to change their thermal properties. We can deflect a rock. But you cannot deflect a black hole. You cannot blow it up. It absorbs energy. Any weapon you fire at it only makes it stronger, adding to its mass. If a rogue black hole, large or small, is on a collision course with the solar system, there is no Bruce Willis movie solution. There is no mission to save the Earth. There is only mathematics. And the mathematics of the Milky Way are chaotic. We used to think the galaxy was a clockwork mechanism, predictable and stable. But the Gaia mission has revealed that our galaxy is still crashing into things. We are currently colliding with the Sagittarius dwarf galaxy. We are absorbing the Magellanic Clouds. These galactic collisions stir up the pot. They disrupt the orbits of stars and, inevitably, the orbits of the hidden wanderers. Every time a dwarf galaxy passes through the Milky Way, it shakes the hive. It sends gravitational ripples that can dislodge rogue black holes from their stable paths and send them careening into the populated zones of the galactic disk. We are currently living in a calm period of galactic history. The solar system is bobbing gently through a relatively empty patch of the Orion Arm. But this is a temporary luxury. As the Sun orbits the galactic center, completing a lap every 230 million years, we pass through denser regions. We pass through spiral arms packed with gas clouds and newborn stars. And we pass through the graveyards of dead stars. We are moving targets in a shooting gallery that resets every few million years. The scariest part of this invisible ocean is not the monsters we know about. It is the speed at which our understanding is changing. 10 years ago, we thought rogue black holes were a theoretical curiosity. Today, we estimate there are billions. 10 years ago, we thought gravity waves were impossible to detect. Today, we hear the universe ringing like a bell every time two black holes collide. The veil is being lifted. And as our vision improves, the darkness is becoming more crowded. We are like a swimmer who has just put on a diving mask for the first time. Before the mask, the water looked blue and empty. With the mask, we suddenly see the shapes moving below our feet. The shapes have always been there. We were just blissfully ignorant. Now, the ignorance is gone and replaced by a cold, hard question. The question isn't, is there something out there? The question is, what is the trajectory? Because in orbital mechanics, a miss is as good as a mile, but a hit is absolute. And while the galaxy is vast, time is long. Over a long enough timeline, the probability of an encounter approaches 100%. It has likely happened before, in the deep geologic history of the Earth, perhaps triggering one of the mysterious mass extinctions that paleontologists cannot explain. And it will happen again. The only variable is when. As we look at the stability of our planets today, we see a system that looks ordered. Jupiter protects us. The Sun holds us. But this order is an illusion maintained by the absence of a disruptor. It is a fragile piece. And as we are about to see, when that piece is broken, it doesn't happen slowly. It happens with the violence of a god snapping its fingers. The arrival of a rogue black hole would not be a slow decline. It would be an abrupt, chaotic rewriting of reality itself. If reality were to be rewritten, it would begin with the light. The first sign of a rogue black hole entering our solar system would not be a sound or a tremor. It would be a hallucination in the sky. As the object crossed the orbit of Neptune, invisible and silent, its gravity would begin to grab the photons traveling from distant stars. To an observer on Earth, the constellations would appear to melt. The familiar shape of Orion or the Big Dipper would twist and stretch, swirling around a point of invisible darkness like oil paints mixing in water. It would be beautiful for exactly as long as it took for us to realize what it meant. By the time the intruder crossed the orbit of Jupiter, the beauty would be replaced by orbital chaos. Jupiter, the king of planets, acts as the gravitational shield of our system. But against a black hole with 10 times the mass of the Sun, Jupiter is nothing more than a marble. The gas giant would be dragged off its course. Its 69 moons would be stripped away, flung into the void like confetti. And this disruption would send a gravitational shockwave inward. The delicate balance that keeps Earth in its habitable zone, that perfect Goldilocks distance from the Sun, would be shattered. Let us run the simulation of the worst-case scenario. The black hole does not hit Earth directly. Instead, it passes between Earth and Mars. As it approaches, the night sky would be dominated by the Einstein ring. This is a circle of warped light, a funhouse mirror composed of the entire galaxy behind the black hole, bent into a blinding halo. But on the ground, the physics would be apocalyptic. The first thing we would feel is the tides. The moon pulls our oceans a few meters. This object would pull them kilometers. As the black hole reached its closest approach, the water of the Pacific and Atlantic Oceans would not just rise, it would be levitated. A wall of water, kilometers high, would sweep across the continents, scrubbing the land clean of cities and forests. But the water is the least of our problems. The Earth is solid, but it is not rigid. It is a ball of rock and magma held together by its own gravity. The tidal forces of the black hole would stretch the planet itself. The crust would flex. Every fault line on Earth would rupture simultaneously. Supervolcanoes like Yellowstone would erupt instantly, choking the atmosphere in ash. The ground beneath our feet would rise and fall like the chest of a breathing giant. And then, the cold would come. This is the rogue Earth scenario. The gravitational kick from the passing black hole would likely be strong enough to eject Earth from its orbit around the Sun. We would not be destroyed, we would be evicted. The Earth would be flung out of the solar system at tens of thousands of kilometers per hour, sailing away from the warmth of our star and into the eternal night of interstellar space. The Sun would shrink in the sky, becoming just another bright star, and then fading into the background. Within weeks, global temperatures would plummet. The oceans would freeze over, creating a layer of ice kilometers thick. The atmosphere would eventually condense and snow out as liquid nitrogen and oxygen. The only heat remaining would come from the planet's molten core. Any survivors would have to live in bunkers deep underground, huddled around geothermal vents, knowing that they are drifting through the void on a dead, frozen spaceship that will never see a sunrise again. This is not a fantasy. It is a fate that has likely befallen billions of planets across the universe. We call them rogue planets. Worlds that were kicked out of their systems by migrating giants or passing black holes, destined to wander the dark forever. We could be next. The universe does not care about our civilization. It does not care about our history or our future. It operates on the laws of mass and momentum, and in that calculation, we are negligible. We often look at the night sky with a sense of wonder. We see it as a canvas of potential, a frontier waiting to be explored. But the existence of rogue black holes forces us to look at the sky with a different emotion, caution. We are like a primitive tribe living on a small island, building canoes, unaware that the ocean surrounding us is full of leviathans that could swallow our entire world without even noticing. The scary part isn't the malice of the black hole. It is the indifference. A predator in the jungle kills to eat. It has a motive. A rogue black hole destroys simply because it is there. It is a force of nature in its purest, most terrifying form. It reminds us that our stability is an accident. We live in a shooting gallery, and for 4.5 billion years, the bullets have missed. But the gun is still firing. However, there is something even more terrifying than a monster knocking at your door. A monster is something you can define. It has mass, it has a location, it has a trajectory. A rogue black hole, for all its horror, is something. But what happens when you encounter nothing? What happens when the universe stops making sense entirely? We spend so much time worrying about the dense, heavy monsters crashing through the galaxy, that we ignore the places where the galaxy seems to be broken. If the idea of a rogue black hole crashing into the solar system keeps you up at night, there is a region of space that will give you a different kind of nightmare. A place where there are no stars, no black holes, and no galaxies. A spherical void so massive that it defies the laws of cosmology. We call it the Boötes void. It is not just empty space, it is an anomaly that shouldn't exist. While a black hole is too much matter in one place, the Boötes void is a chilling absence of everything. Some theories suggest it isn't just an empty room, but a growing bruise on the universe, or perhaps, the result of a civilization far more advanced and far more dangerous than a simple black hole. If you want to understand why nothing is scarier than something, and see the true face of cosmic horror, you need to see our investigation into that abyss. Click the video on your screen now to enter the Boötes void. It makes the rogue black hole look like a simple physics problem. Go there now, and see what true emptiness looks like. Until next time, keep looking up.